Hey y'all, today is January 31st and I'm going over the Topic 5 Part 1 study guide. So this is very similar to your test, so pay close attention and let's get started. So number 1, we have negative 15 equals y minus 2. I'm going to draw my line down my equal sign to remind me that whatever I do on one side, I must do on the other side. And remember, we're trying to get this y right here by itself, and it's connected to a minus 2. So how do I undo minus 2? Well, I add 2. So I'm going to add 2 on both sides. Now on the side with the y, my 2's cancel out, and y comes down, and y is by itself. On the other side, I have negative 15 plus 2, which is negative 13. So negative 13 equals y is my answer. Keep in mind, it's the same thing if I say y equals negative 13. I don't care how you write it. Moving on to number 2. The first thing we're going to do, draw our line through our equal sign. Now I have a divided by negative 3 equals negative 12. Well, notice how a is connected to negative 3. It's being divided by negative 3. How do I undo dividing by negative 3? Well, I multiply by negative 3. So I'm going to do that on both sides. On the side with the a, my negative 3's cancel out, and notice a is now by itself. On the other side, I have negative 12 times negative 3, which is positive 36. Number 3, write an equation and solve it. Richard harvested half as many sweet potatoes as carrots. If there were 22 sweet potatoes, how many carrots did he get? Okay, so we're trying to answer this question here. So I'm going to let my variable relate back to that question. So x is the number of carrots. Okay, so what is some important information that I might circle? Well, he harvested half as many, and there were a total of 22 sweet potatoes. Okay, notice how I said that. There were a total of 22 sweet potatoes. So where does that 22 go in my equation? Well, it goes after my equal sign. So I'm going to have equals 22. Now, that means on the other side over here, I need something to represent half, and I know my variable x has to go over there too. Well, half. Let's talk about that for a minute. I can represent that several different ways. It can be a decimal, 0.5. It could be a fraction, 1/2. Or I could take my variable and divide it by 2. All of those will represent half. And I don't care which one you use. I'm going to do 1/2 times x equals 22. So that's my equation that I'm going to solve to get my solution. So I'm just going to rewrite it. 1/2 times x equals 22. So draw a line through my equal sign. Now to get that x by itself, I could divide by 1/2, and I can use my calculator to do that. But dividing by 1/2 is the same thing as multiplying by the reciprocal. Well, what is the reciprocal of 1/2 or 1 over 2? It's 2 over 1. I just flipped that fraction upside down. Well, if I multiply by 2 over 1, isn't that the same thing as just multiplying by 2? Yeah, it is. So that's what I'm going to do. I'm going to multiply by 2 on both sides. So on the side with the x, everything cancels out except for x. And on the other side, I have 22 times 2, which is 44. So my solution is 44. 44 what? 44 carrots. Moving on to number 4. We're going to draw our line through our equal sign. We have 5p equals negative 65. Well, to get that p by itself, I have to divide by 5 on both sides. So on the side with the p, my 5's cancel out and p is by itself. On the other side, I have negative 65 divided by 5, which is negative 13. Okay, moving on to number 5. This time I have a two-step equation. So I'm going to draw my line through my equal sign. And note that I'm trying to get this m by itself. So I start farther away from my m and work my way in close towards my m. So farther away from my m is this minus 2. That's what I need to undo first. How do I undo minus 2? Well, I add 2. And I do that on both sides to keep my equation balanced. So on the side with the m, my 2's cancel out, and I'm left with 12m. On the other side, I have 82 plus 2, which is 84. Now to get that m by itself, it's connected to 12 through multiplication, so we undo that by dividing. Dividing by 12 on both sides. So on the side with the m, my 12's cancel out, m is by itself. On the other side, 84 divided by 12, if you use your calculator, you're going to get 7. So 7 equals m is our answer. Number 6. Okay, the first thing I'm going to do here is draw a line through my equal sign. And note, I'm trying to get this y by itself. But what I need you to recognize about a problem like this is that negative 1 plus y, that's like grouped together. So I don't want to undo that part first because this whole group is being divided by 5. So the thing that I want to undo first is the dividing by 5. Well, how do I undo dividing by 5? I multiply by 5. So I'm going to do that on both sides. Now on the side with the y, my 5's cancel out, and I'm left with negative 1 plus y equals, now on the other side, negative 2 times 5 is negative 10. Now I'm still trying to get that y by itself, so I have to undo that negative 1. I undo that by adding 1 on both sides. So my 1's cancel out, y is by itself, negative 10 plus 1 is negative 9. Moving on to number 7. So I'm trying to get this x right here by itself. And I work my way farther away from my x in close towards my x. So what's farther away from the x? Well, this negative 10. How do I undo that negative 10? I add 10. So I do that on both sides. On the side with the x, the 10's cancel out, and I'm left with negative 2x equals, on the other side, negative 14 plus 10 is negative 4. Now, x is connected to negative 2 through multiplication, so I undo that by dividing by negative 2 on both sides. So my negative 2's cancel out, x is by itself, negative 4 divided by negative 2 is positive 2. Number 8, 9 equals 5 plus v over 3. So I'm going to start by drawing my line through my equal sign. And I know I'm trying to get this v right here by itself. But I have to undo something farther away from that first. Well, what's farther away? This 5. What kind of 5 is that? It's a positive 5. So how do I undo a positive 5? I subtract 5. So I'm subtracting 5 on both sides. Now, on the side with the v, my 5's cancel out, and I'm left with v divided by 3. On the other side, I have 9 minus 5, which is 4. Now, on the side with the v is being divided by 3. Sorry, positive 3. V is divided by 3. How do I undo divided by 3? I multiply by 3. So I'm going to do that on both sides. On the side with the v, my 3's cancel out. V is by itself. On the other side, I have 3 times 4, which is 12. So 12 equals V is our solution. Number 9. I'm going to draw my line through my equal sign, and I'm trying to get this A by itself. Remember, we start farther away from our A and work our way in close towards it. So what's farther away? This minus 8. How do I undo minus 8? Well, I add 8. So I'm doing that on both sides. Now on the side with the A, my 8's cancel out. I'm left with negative 3A equals, on the other side, negative 20 plus 8, negative 12. Now, to get my A by itself, it's connected to negative 3 through multiplication. I undo that by dividing by negative 3 on both sides. So my negative 3's cancel out. A is by itself. Negative 12 divided by negative 3 is positive 4. Number 10, we've got negative 2 plus 3 over 2 times x equals negative 14. We're trying to get this x by itself, but we have to start farther away from our x and work our way in close towards the x. So what's farther away? This negative 2. Well, how do I undo a negative 2? I add 2. So I'm adding 2 on both sides. So on the side with my x, my 2's cancel out. I'm left with 3 over 2. X equals, on the other side, I've got negative 14 plus 2, which is negative 12. Now to get that x by itself, I'm going to multiply by the reciprocal. So I'm actually going to multiply by this fraction flipped upside down. So multiply by 2 over 3. And I do that on both sides. Now on the side with the x, my 3's cancel out. My 2's also cancel out. That means x is by itself. Now on the other side, I think it's helpful if I write it so I have two fractions. So I'm going to write this as negative 12 over 1 times 2 over 3. Now does anything reduce? Well, looking this way, 1 and 2 don't reduce. But what about this way? 12 and 3 do reduce. 3 goes into both. 3 goes into 3 one time, and 3 goes into 12 4 times. Okay, so now I notice my denominators are both 1. So I can ignore the denominators. I'm just multiplying my numerators together. So my numerators are negative 4 times 2. Well, negative 4 times 2 is negative 8. So x equals negative 8 is our solution. Number 11, 1/3 x minus 13 equals negative 17. So we're trying to get that x by itself. And remember, we start farther away from our x and work our way in close towards the x. So what is farther away from the x? Well, this minus 13. How do I undo minus 13? I add 13. So I'm adding 13 to both sides. Now on the side with the x, the 13's cancel out, and I'm left with 1/3 x equals, on the other side I have negative 17 plus 13, which is negative 4. Okay, now how do I get this x by itself? Well, it's connected to a fraction, so I'm going to multiply by the reciprocal. So what is the reciprocal of 1/3? Well, it's the fraction flipped upside down, 3 over 1, or just 3. So I'm multiplying by 3 on both sides. On the side with the x, everything cancels out except for x. On the other side, negative 4 times 3 is going to be negative 12. So x equals negative 12 is our solution. Okay, so now we have a couple of word problems again. So we have to write an equation and solve it. So this year, the Pirates football team has 5 more than double the number of players as last year. If there are 135 players this year, how many were there last year? Okay, we're trying to answer how many players there were last year, right? So let's let x equal the number of players last year. Okay, so what is some important information that I might circle? Well, 5 more, double, and 135. Is one of those numbers a total? If you said 135, you're right. So where do my totals go in my equation? They go after my equal sign. So I'm going to go ahead and write equals 135. Okay, that means on the other side, over here, I need something to represent double, 5, and my variable has to go over there. So I've got 2 numbers left. I've got double and 5 more. Which of those numbers is attached to my variable x? Well, double, because double means twice, right? So I'm multiplying this with my x. So 2x. Now, the last part is the 5 more. And more is a key word because it means I want to do what operation between 2x and 5? I want to add. So 2x plus 5 equals 135. Now, that's an equation you should know how to solve. I'm just going to rewrite it. Okay. And we're going to solve it like normal. I'm trying to get that x by itself, so start farther away from the x. That means we're starting with that plus 5. How do I undo plus 5? Well, I subtract 5. Oops. And I'm subtracting 5 on both sides. Now on the side with the x, my 5's cancel out and I'm left with 2x. equals, on the other side, 135 minus 5 is 130. Now to get that x by itself, I'm dividing by 2 on both sides. So on the side with the x, my 2's cancel out. X is by itself. 130 divided by 2 is 65. 65 what though? 65 players. So 65 players. Okay, moving on to number 13. A third of the gas in the tank was used when Melanie drove to visit her sister. She put 4 more gallons of gas in the tank when she got there. After putting in gas, she had 12 gallons in the tank. How much gas did she have before she drove to her sister's house? Okay, so we're trying to figure out how much gas she had. So we're going to let X represent the number of gallons of gas. Okay, what is some important information that I might circle? Well, a third. She put 4 more gallons in, and she had 12 gallons in the tank. Is one of those numbers a total? If you said 12, you're right. So where does that go in that equation? It goes after my equal sign. So equals 12. That means on the other side over here, I need something to represent a third. I need 4 more, and I need my variable x. So of the 2 things that are still left, third and 4 more, which of those is attached to my variable x? If you said a third, you're right. And remember, a third is simply the fraction 1/3. So I have 1/3 x, and I also have a 4. And the key word is 4 more. That means what operation are we doing to connect these? We're adding. So 1/3 x plus 4 equals 12 is our equation. We know how to solve that. So that's what we're going to do to get our solution. Okay, so we're going to draw our line through our equal sign. Now the first thing I want to undo is that plus 4. How do I undo that? Well, I subtract 4. And I'm doing that on both sides. So on the side with the x, the 4's cancel out. We're left with 1/3 x equals 12 minus 4 is 8. Now to get this x by itself, I'm going to multiply by the reciprocal of 1/3, which is 3/1 or just 3. So I'm multiplying by 3 on both sides. So on the side with the x, 1/3 and 3 cancel out. So x is by itself. On the other side, 8 times 3 is 24. Well, 24 what? 24 gallons. So our solution is 24 gallons of gas. Okay, one more word problem here. Number 14. A middle school field trip required 9 buses. 23 children rode in cars with their parents, and the rest rode on a bus. If there were 243 children on the trip, how many were on each bus? So this is one that I told you on Friday. Change this 9 to 5. So there were 5 buses, okay? Now we're trying to answer this question. How many were on each bus? How many children were on each bus? So let's use the variable x. Let's say x represents the number of children per bus, right? Okay, now what is some important information that we might circle? Well, 5 buses. What else is important? 23 rode in cars with their parents, and that there were 243 children on the trip. Okay, is one of those numbers a total? Well, if you said 243, you're right. So I know it goes after my equal sign. So equals 243. Now that means on the other side, I need a 5, I need 23, and I need my variable x. So 5 or 23, which one of those should be connected to my variable? Well, I know x is the number of children per bus and that there are 5 buses. So I think 5 should be connected to x. So we have 5x, and we also have 23. Now let's think about this. Those 23 children, they didn't ride on the bus, they were still included in the total. So if they're still included in the total, Let's add them. So now we have our equation. 5x plus 23 equals 243. So we should know how to solve that. Okay, so to solve that, we're going to draw our line through our equal sign. And the first thing I'm going to undo is that plus 23. And I undo that by subtracting 23 on both sides. So my 23's cancel out. 5x is by itself. On the other side, I have 243 minus 23, which is 220. Now to get that x by itself, I'm going to divide by 5 on both sides. So my 5's cancel out. X is indeed by itself. 220 divided by 5, if you put that into your calculator, you get 44. So 44 what? Well, 44 children per bus. Okay, let's move on to number 15. So the first thing I'm going to do is I'm going to draw my line through my equal sign, and I'm going to simplify my left-hand side. So I know I need to simplify it because I see parentheses. So that means I need to get rid of those parentheses. So I know I taught some of y'all shortcut. You can use the shortcut, but we're going to use the distributive property. So what is negative 4 times 1? Well, negative 4 times 1 is negative 4. Now I'm going to multiply negative 4 times 7n. Negative 4 times 7n is negative 28n. And all of that equals 108. So notice I did not change this side at all. I only changed the side with parentheses. But now this should look like a normal two-step equation that you know how to solve. We're trying to get this n right here by itself. So I'm going to add 4 to both sides. So now my 4's cancel out. I'm left with negative 28n, and that equals 108 plus 4 is 112. Now to get this n by itself, I'm going to divide by negative 28, and I do that on both sides. So on the side with the n, negative 28 cancels out. N is by itself. On the other side, I have 112 divided by negative 28. So my answer is negative 4. Okay, moving on to number 16. So I'm going to draw my line through my equal sign, and I'm trying to get this y by itself. Now I notice I have some like terms over here, so I need to combine some like terms. My like terms are negative 9 and positive 6. And when I combine those, negative 9 plus 6 is negative 3. So I'm going to rewrite this as 17 equals 4y minus 3. Now, this is a normal two-step equation that you know how to solve. So I'm going to add 3 on both sides. My 3's cancel out, and I'm left with 20 equals 4y. Now, to get that y by itself, I'm going to divide by 4 on both sides. So my 4's cancel out. Y equals 20 divided by 4, which is 5. So 5 is our solution. Okay, moving on to the next page, number 17. So I'm going to start by drawing my line through my equal sign. And again, I see parentheses. That means I have to get rid of them. You can use a shortcut, but you can also use the distributive property. So we're going to multiply 2.5 times 1.25. And when we put that into our calculator, we get 3.125. Now we're going to multiply 2.5 times x. 2.5 times x is simply 2.5x. And all of that equals 11. So notice this side here did not change. So now we're ready to solve this like a normal two-step equation. Don't let the decimals throw you off. The first thing I have to undo is this 3.125. Well, it's positive, so I'm going to subtract 3.125 on both sides. Okay, so on the side with my x, 3.125 cancels out. I'm left with 2.5x equals. Now on the other side, I have 11 minus 3.125, And if you put that into your calculator, you get 7.875. Now, to get x by itself, we're going to divide by 2.5 on both sides. So on the side with the x, 2.5 cancels out. X is by itself. And on the other side, 7.875 divided by 2.5 is 3.15. So 3.15 is our solution. Okay, moving on to number 18. Good news is there's no more decimals here. Bad news is I see parentheses. So I'm going to have to distribute. So the first thing I'm going to do, just bring down this minus 8. So we have minus 8, or negative 8. And then now I'm going to use the distributive property. 2 times 1 is 2, so plus 2. And then 2 times negative 4p is negative 8p. And all of that equals 146. So notice the only pieces that changed were the pieces involved in the distributive property. Everything else stayed the same. But now I notice that I have some like terms. Negative 8 plus 2 are like terms. I can combine them. So negative 8 plus 2 is negative 6. So I have negative 6 minus 8p equals 146. Now to get that p by itself, we're starting farther away from the p and working our way in close towards the p, right? So the first thing I have to undo is that minus 6, and so I'm going to undo that by adding 6 on both sides. So my 6's cancel out. We have negative 8p equals 146 plus 6 is 152. Now to get that p by itself, divide by negative 8 on both sides. So p equals 152 divided by negative 8 is negative 19. So that right there is our solution. Now number 19. So I'm going to draw my line through my equal sign. And what I notice here is that I have k's on both sides. I need my k's all on one side. Everything else is simplified. So I notice on the left-hand side, I don't have any like terms or parentheses. Same thing here, no like terms, no parentheses. So I'm ready to start moving things around. And I want to get all my k's on the same side together. So which one of these is smaller? Negative 6k or 1k? Hopefully you said negative 6k. So to move that to the other side, I'm going to do the inverse. I'm going to add 6k. So I'm adding 6k to both sides. So on the side with on the left-hand side, let's say it that way, on the left-hand side, my 6k's cancel out. I'm left with negative 17. On the other side, 1k plus 6k is 7k, and I just bring down that plus 18. Now, to get k by itself, I now need to move this plus 18 to the other side. And this right here is a normal two-step equation. So I'm going to do that with inverse operations. Subtract 18 on both sides. So on the side with the 7k, my 18 cancels out. I'm left with 7k equals, on the other side, negative 17 minus 18 is negative 35. Now to get k by itself, I'm going to divide by 7 on both sides. So my 7's cancel out. K is by itself. On the other side, negative 35 divided by positive 7 is negative 5. So negative 5 is my solution. Number 20. So again, I've got kind of a complex equation here. What I notice on the left-hand side is I have parentheses. So I've got to get rid of those first, and I'm going to use the distributive property. So 4 times 2g is 8g. And 4 times 12 is 48, so plus 48. And I'm going to bring down this minus 6. And all of that equals negative 14. Now on the left-hand side, again, I notice I've got like terms. 48 minus 6, I can combine that. 48 minus 6 is going to be 42. So I'm going to rewrite this as 8g plus 42 equals negative 14. Now this is a normal two-step equation. We're going to subtract 42 on both sides. So my 42's cancel out. 8g is by itself. Negative 14 minus 42 is negative 56. Now to get g by itself, I'm going to divide by 8 on both sides. So g equals negative 56 divided by 8 is negative 7. Okay. And I'm going to do the last 5 in another video.